So these are the notes for 3x3 elimination, which is week 2, set 2, SWYK 2 notes. I want to go through this as quickly as possible, but it is a little bit more complicated than elimination, substitution. So I've tried to write things out as we go. The idea here is that I want to, when I take a look at this, you'll notice that the first equation has A and B in it, but no C. Then I look at the bottom equation and I go, oh, look, they both have the same C's. So we can do addition or subtraction, but in this case, subtraction would be the easiest because 4C minus 4C is going to make those two things disappear. Well, if you do 8A minus 6B, guess what? You get 8A minus 6B. And then over here you get 4 minus negative 24, and 4 minus negative 24 is obviously 28. Okay, next in the list, if you take a look at this, you notice that you have 4 A's and 8 A's. I want those to be opposites of each other. So what I chose to do is multiply the top equation by negative 2. When I multiply the top equation all the way through by negative 2, I got negative 8A minus 14B equals 12. Now you can see that I'm going to add these two equations together. And guess what happens? Elimination. Just like we did when we subtracted the first two equations, we got rid of the C's. Now we're eliminating the A's. And when we do that, negative 14b minus 6b is negative 20b, and 12 plus 28 is 40, and now I can divide by negative 20 on both sides and get negative 2. So now we know that the b value is negative 2. How do we find the a value? Guess what? Plugging it back in. You can pick your favorite equation that has an a and a b in it, so I did that. And I always like to deal with as many positives as I possibly can and smaller numbers. Sometimes you don't have a very good choice. So then, of course, negative 6 times negative 2 is positive 12, so I'm going to subtract 12 to the other side, giving me 8a equals, 16? So when I divide by 8, I find out that a is positive 2. So we got a is 2 and b is negative 2. So go back and pick an equation that has something I can use here, such as 8 times positive 2, because that's a, plus 4 times c equals 4. Now I'm trying to find out what c is. So we know that's 16, so I'm going to subtract 16, and so we have 4c equals negative 12, and so c equals, man, I'm running out of room here, negative 3. So the answer to our question is a is 2, b is negative 2, c is negative 3. Okay, so that takes care of that one. All right. Pause if you need to anytime in these videos to make sure you can write things down. I just got to keep moving because I got to keep the video under 7 minutes or close to it. But this might be a trick. All right, so when I look at this particular question, right here, I see that those are not equal, but I can make them equal or opposite of each other. So you'll notice that what I'm trying to do is I'm trying to either make them 6b or negative 6b. Now, could I have chosen to do the same thing with the c's? Sure, it could have. It would have been a lot more complicated with the a's because then you would be trying to make everything equal to 44a. So it wouldn't matter. Some of this is going to get ugly the way it is. So I decided to multiply the top one by 2, the middle one by 2, the bottom one by 3. And so what it did was it changed it into these three equations right here. You can see I drew the red arrows to help you through the process. Now, I'm going to slide the screen over, and you're going to see that what I chose to do was I chose to add the top two equations together because I saw this. All right, and when I did that, you can see I get this equation, 10a plus 6c equals negative 2. Then I said, oh, look, I got a positive 6b and a negative 6b. So I'll take the first one and the third one and add them together. Okay, so when I do that, I get this equation right here. All right, so now you're saying to yourself, I got to do more elimination, and none of those are nice numbers. Well, you are exactly right. So what I chose to do was I chose to multiply this one by negative 11. And I chose to multiply this one by positive 6. All right? Negative 11 to the top row, positive 6, and so I ended up with these two equations right here. Now you can see that they both have, one has negative 66c and one has positive 66c, and when you add them together, the a's give you 136a, and the constants on the right give you 136. Oh my goodness, that makes it so much nicer. I get an a value of 1. So now I need to pick an equation to figure out what c is. So I'm going to do 10 times 1 plus 6c equals negative 2. That's positive 10. So if I subtract 10 to the other side, I get 6c. Ooh, that's a bad look at 6 equals negative 12. So we can see that c is equal to negative 2. So we got an a value of 1 and a c value of negative 2. Moving on over. A value of 1, c value of negative 2. Okay, so now pick an equation that has a's, b's, and c's in it. It really doesn't matter what it is. If you want to go back to the beginning, something with small numbers, that's quite all right. But if I want to use what's on screen at the moment, I'll do this. So 8 times 1 plus 6b plus 2 times negative 2 equals 28. Let's see here. So 8 minus 4, that's 4. So we'll subtract 4 to the other side. That'll get rid of that. So 6b equals 24, and divide that out. And we find out that b is equal to 4. Okay, so we now know that the coordinate 1, 4, negative 2 is the correct solution to this system of 3 equations. Okay, 2 more examples here. I'll try to speed this process up a little bit so you can kind of follow along and maybe understand a little bit what I'm doing here. So when I looked at this, I said, hey, I decided I wanted to get rid of the x's. So everything's going to be either 9x or negative 9x. And so I multiplied the middle row by negative 3 and the bottom row by 9. That got me over to here. So then I matched up the first 2 equations and the second 2 equations. And when I got to that point, then I had these 2 equations. So I said, all right, now I've got some ugly numbers. What am I going to multiply by? I went with positive 27 to the top row and negative 10 to the bottom row. You can see how that changed my equations, got me over to here. And then I was able to add them together because the z's disappeared, right? Giving me a y value. Oh, look, my y value was equal to 1. Then I'm going to go through the process just like I did before, plug it back in, pick an equation. You know, if you want to use this equation, you can. If you want to use one that has smaller numbers, you can. It just means that you have to, so I probably would have gone back to one of these other equations, something with smaller numbers in it, maybe even this one right here. Plugged in my y, found out what my z was, and then continued on back. And you can do this question for practice. I want to show you one little detail in the last one and then be done since I'm already over my time limit. So I noticed that the first 2 equations had x's, but the bottom one didn't. So what I decided to do was multiply the middle equation by negative 4. Now, I did write that up here above this one so you could see, oh, look, those are going to cancel out. And when I added those 2 equations together, that's what I got right here. Now you'll follow the red arrow and you're like, well, those are different equations. Well, you can tell that what I did was I multiplied by 4. The reason I multiplied by 4 was so that we could get this situation to occur, figure out what z was. Obviously, z is 1, and now I'm going to go through the process, pick an equation, maybe go back to here, find out what y is. Once I find out what y and z are, maybe I go back to one of the original equations to find out what x is. For those of you at home that are wondering what the solutions are to those questions, you can see those things right here on screen. Okay? Sorry that video was longer than I wanted it to be. Have a great week. That's the end of our video instruction for this week.